sense of where we are. I think, would you agree that there weren't any surprises on that quiz? Life is hard sometimes, Jake.
Our quizzes and test work weights.
Different.
Okay. So, let me turn this on. Yep. All right, so here we go. We're going to finish up our notes, I think, today. If not, we'll for sure get them done next time. But I think we only have a little bit more here to do. So you will recall that what we were doing last time was implicit functions. And what do you remember about that? What basically all we did was what?
It's like the F of G.
No. No. Implicit functions.
It was like if it was a circle, you had to do like you can't graph it like as it is, so you have to make it the way that you can graph it.
So which meant we got y by itself. So when we look at this equation, when we look at this equation, we have to get y by itself. Okay? Now, you guys, listen. This first step is easy, right? Now, tell me about this. Can I draw the absolute value? Yes, as long as what? What's in there is positive, right? So if y is positive, then my equation is just going to be y equals 1 minus x. Would you agree with that? But what if y is negative? What if this is like -3? Then what does it become? If y is -3, it becomes positive 3. So in other words, if the number that's in there is negative, when I get rid of the absolute value, its sign changes. So I write that this way. Now I know you're going to freak out, some of you, and say, well, absolute value can't be negative. No, this doesn't say negative. This actually would become positive because y is negative.
So just say opposite of y.
Opposite of y. Yeah, it looks like a negative, but it's opposite of y. And then that equation becomes x minus 1. Divided by that negative, it's positive x minus 1. So here are your implicit functions. Now we don't have time to graph that, but what's this shape right here? It's a line. And so is this one. So if I graphed those two lines, I would have some x then as my picture. But when I take these into account, then I don't have the whole x. I have just this part of the x. This part's gone. Does that shape make sense for this equation? Yes, because what do absolute values look like? V's. But when it's a y in there, the v is sideways. Okay? So when you do your implicits for an absolute value, for the first one, you get the y by itself. Then, for the first one, just drop the absolute value. Just write it. For the second one, make this the opposite of y, as Jake says. And that will give you the second equation. Let's go down and do f. it's another absolute value. So what's the first thing you're gonna do?
Move X over.
Move X over. Now be careful, when you move X over, that's gonna be negative, right? So I'm gonna divide that out, and I'm gonna have X minus 1, positive X minus 1. So then I split this up. So my first one will just be y equals x minus 1. Write the implicit functions. It's going to be, first one is just that. Then the second one, I have to do negative y, or opposite y, equals x minus 1, which means y will equal negative x plus 1. Right? If I divide by negative 1.
So just basically just like add, subtract.
Yeah. Yep. So my implicit function, here's 1 and here's 1. Letter D is like the ones we did yesterday. Letter D is like the ones we did yesterday. Y squared equals x squared. So what do we do? Square root. And what do we remember when we square root? Y equals plus or minus x. That's it. Those are your two equations. Y equals x, y equals negative x. Okay?
Why can't you do the same for the implicit equations? Or like the x minus 1, why can't you just do plus minus x minus 1? Because we have to change it.
We're not square rooting those signs,
Okay.
right? Okay. Now, Joe Gardy, that may be what ultimately ends up happening, but there's no mathematical reason behind it. All right, 3 more problems, and we're done with these notes. We'll have a test over 1-1 to 1-4. Here we go.
Test.
Find, oh my, wait a minute. This is tricky. There are 2 mystery functions out there somewhere. I don't know what they are, but when I put them together, this is the answer that I get. Okay? So here's how I want you to think about this. This can be a little perplexing. Look at this right here. If you gave it a number, if I said plug in 5, what is the first thing you would do? You put it in, and then you would multiply by 2 and subtract 1. So one of your functions has to multiply by 2, and the other function has to subtract 1. You're trying to break this back down into 2 little functions. Now, which one comes first when it's written this way? G. So you told me the first thing that had to happen was I had to times by 2. So g of x is the function that takes an x, takes a number, and times it by 2. Okay? Now, what is f going to have to do then? Minus 1. So f is going to be the function that takes something, x, takes a thing, and subtracts 1. Remember, f is going to take your answer to this and subtract 1. Okay. What did you say we get when we put 5 in here? 9. Okay. Let's do it step by step. What do I get if I plug 5 in the G? 10. Then I'm going to take that 10 and plug it into F. What am I going to get? 9. This is what the function looks like that subtracts 1. It takes a thing and subtracts 1. This is what the function looks like that takes a thing and times it by 2. So I need to times by 2, subtract 1.
Is 9 part of the answer?
9 would be the answer if there were 5 in there. This is the answer. Your job is to find the 2 functions that when you put them together, they accomplish that. All right, let's look at the next one. You have to do the same thing. You have to find an F and a G that makes this happen. All right, so think about, pick 5. Think about putting 5 in here. What would be the first thing that the function would do?
Add.
First, it adds 2. So I need my first function to add 2. What do I need my second function to do? Squaring. Okay? Now, in this, which one is first?
Square. Oh, G.
G. So G must be the function that takes a thing, always X, and adds 2. And then F is going to be the function that takes a thing, always X, and squares it.
And that's what it
That's all you have to do. Start with this, guys, and build this composition for me. Wouldn't this say take X plus 2? And then take that and plug it into F? And what would you get? X plus 2. It works. Trust me, it works. Every time.
Okay, that makes sense.
In my quest to be, I don't know, in a hurry, I didn't do the last one. Let me do the last one. Let me fill in the problem. I forgot to fill in the problem. Let's do, let's switch it up and say G of f of x is x plus 3 over 7. So your job is to find f and g. We know one of them is going to add 3, and one of them is going to divide by 7, right? But you got to do it in the right order. What order, what function do I start with? F. So f is the function that takes x and adds 3. Now what is g going to do?
Divided by 7.
G is going to take x, just x, and divide it by 7. Because when you do that composition, you plug f into g. So you would take this and put it here. See how that works?
Yeah.
So when you build these functions, you're just using x. All right? Now, I'm going to give you a challenge problem, and then I'll shut up, okay? Hang on for 1 minute. Find 2 functions that would end up being this. Now, why is this a little bit challenging?
Because there's 3 components.
Because there's 3 components. There's 3 things happening, and you've only got 2 functions to get it all done in. So what does that automatically mean? One of the functions is going to have to do 2 things. Okay? So what does it make sense? What are the things that have to happen? We have to square, we have to add 3, and we have to divide by 4. So how do you want to split it up?
X squared plus 3.
So f of x
Equals
can be x squared plus 3, right? And if you do, if you do it that way, what will g have to be? X divided by 4. what if somebody else says, I want F to be x squared?
Still works.
It'll work. What does G have to do then?
X+3.
G has to add 3 and divide by 4? It doesn't matter, as long as you get all 3 things done in the right order, you can split it up any way you wish.
Yeah.
All right, 1.1 homework will be due on Friday. Doesn't matter, actually you do, Joe, but I think I passed it by.
Yeah, I should. I'm glad this is something